All right, so we're going to talk about geometric series. And if you remember, a series is the sum of the terms. So if I have the sequence 2, 6, 18, the series would be 2 plus 6 plus 18. So if we say find the sum of the first 20 terms of the series 2 plus 6 plus 18, the formula that we will use is this. The sum of the terms equals the first term minus the first term times the common ratio raised to the n, which is the number of terms. And you're going to divide that by 1 minus the common ratio. So let's take a look at the sequence that we have, 2, 6, 18. Well, the first term is 2, so we'll put that in for A1. You can see that 2 times 3 is 6, 6 times 3 is 18, so the common ratio is 3. It asked me for the first 20 terms, so n is 20, and then 1 minus r would be 1 minus 3. Just put this in your calculator, and you'll see you get a very, very large number. When you're adding up the terms of a geometric sequence, you're going to see that it's going to get large very quickly. Here's another example. Find the sum of the first 8 terms of a series. Leave answer as a fraction. So now you can use the fraction button in your calculator when you're solving this. So the series is 6, negative 3, 3 over 2, and minus 3 over 4. Notice that the signs switch when you're going from one term to the next. So the first term is 6. If I'm going from 6 to negative 3, I'm dividing by 2. But it's a negative sign, so I'm dividing by negative 2. When I'm going from negative 3 to 3 over 2, I'm dividing by negative 2 again, and so forth. If I'm dividing by negative 2, it's the same thing as multiplying by negative 1/2. So my first term is 6. My common ratio is negative 1/2. It asked me for the first 8 terms, so n is 8. And I just put this all in my calculator. It asked to leave it as a fraction, so the reduced fraction would be 255 over 64. We could also do this in summation notation. So here it says find the sum, and it gives you this expression in summation notation. So you need to kind of pull this apart to see what you have. So here's the formula that we'll use. So we know that we need to find A1, we need to find R, and we need to know what n is. Well, in summation notation, the thing that's after the summation symbol is what your AN is. And AN is A1R to the n minus 1. So in this case, we know that AN has to be 3 to the n because it has 3k here. So if I plug in 1 for n, I know that A1 would be 3 to the 1, or just 3. So now I know what A1 is. R is always the thing that is raised to the exponent, so R would be 3. And it told me up here that n is 6. Now I have all the variables that I need to plug into my formula and put this into my calculator and solve. Here's another example, but this one's a little trickier because it's starting at the third term. It's not starting at the first term, so you have to be a little bit careful about this. So here's the formula that ultimately I'll be using. But what I really need to plug in is A3 minus A3 and R to the n over 1 minus R, because this particular sum is starting at the third term. Since k starts at 3 and ends at 9, I know there are 7 numbers. So 3, 4, 5, 6, 7, 8, 9, those are 7 numbers. Another way you can do this is take 9 minus 3 is 6, but that's going to tell you how many differences there are. So if you want to find out what n is, you're going to have to add one more to that. A3, I'm just going to have to plug 3 in now for k in this expression. So 5 times 2 to the third. 2 to the third is 8 times 5 is 40, so I know the third term would be 40. My r is always the thing that's being raised to the exponent in this an expression, so r is 2. Now that I have all those numbers, I can plug them into my formula and put it in my calculator and solve.